Um, so thanks everyone. Let me start this conversation by saying thanks to the EC Council team for inviting me into this esteemed conference that they are arranging today. Thank you so much for that. And I would also like to thank all the audience for sparing your time and coming on to attending this conference. I know I was looking at some of the demographics of the attendees that are joining this session. Looks like some people are joining from all three continents, be it US, Europe, and others in Asia Pac. So thank you so much for that. For some, this time around, maybe an early morning. For some, it could be a late night and henceforth. So thanks for that. Without any delay and respecting your time, let me start this presentation. So today I'm going to be talking about and sharing my experience on the IoT. So we'll give you a quick brief of what is IoT, what is the future looks like for IoT, and what are the relevant essentials or the security elements that we have when we talk about the IoT. In the end, I'm also going to be sharing a case study which I'll be sharing based on my previous experience, and I'll be giving you few tips as to how you can really go and build the secure IoT system in some place. And I'll also be giving you few tips. These are all generic tips based on my experience, which I think are essential for you to be successful in the career. Thanks. All right, let me move on with the IoT. As you may all be hearing a lot about IoT, Internet of Things. This is kind of a buzzword. You may be hearing about autonomous cars. You may be hearing about the connected factories. You may be hearing about the wearables that we are having. These are all connected to the internet, the smartphones. So if we really go back to the definition of IoT, the definition I've just extracted from the Wikipedia. This looks very simple and modest. So it says that IoT basically is nothing but a network of physical objects that is nothing but things and which are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging the data. So this is important. So one, that IoT device connects, and the other is it also goes and exchanges the data. Why I'm emphasizing on these two words is because the moment something is getting connected onto the internet and they start sharing some data, that's where you would be able to easily relate this to the cybersecurity. And also it does the data communication with the other devices and the systems over the internet. There are few examples. And in the examples, if you look at, I think these are the four categories that I have tried to create, and indeed 4 categories I have tried to summarize this into 2, industrial and consumer. So let's talk about the consumer first. When we talk about the consumer IoT, this is something that is touching to us directly in day-to-day life. So say, for example, the wearables, if we are wearing the smart watches, if you're having the smartphones, if you're having the TVs, which are also connecting to internet, these are all the examples of Internet of Things. Similarly, at our home, we now have appliances which are IoT enabled. Those appliances are basically going and sending all the data with respect to the availability of the appliance, with respect to the usage pattern of the appliance, with respect to how the appliance is behaving at some point of time in the whole day. So all of these data it is generating and sending onto these servers. Similarly, the home monitoring systems have now started coming, which are also IoT enabled. You have home automation systems, which basically automate everything. So imagine if someone's home is completely automated with IoT, and what if that hacks? So your entire privacy and everything goes for a toss. So we'll discuss these things a little later. If we talk about flip the coin to industrial, in industrial we see heavy machineries, those are coming in with IoT. enabled the transportation system. You may be hearing driverless cars, the autonomous cars. These are all the great examples of IoT. Smart cities, in some parts of the world, those are already there. In the developing world, these are also getting created, which is going to be completely IoT based cities. So everything will be just on the phone. Similarly, when you look at the other part of the industrial, which is nothing but into the factories or plants, all the connected machines are coming in, the automation systems are coming in. If you look at the healthcare, all the newer devices that are coming in, those are also going and generating a lot of data. You can go and control those devices remotely. So there are a lot of examples. These are just a few, but there are a lot of examples that we see today. Those are there from on the IoT space, be it the consumer or the industrial. And as the world is emerging, the newer technologies are going on, and we have seen with pandemic, this COVID-19 pandemic, the technology adoption has really gone up so high. So we'll see that the IoT devices would also be adopting at a very fast pace as we move forward. So even companies the people are actually going and talking about connecting all the trees, connecting all the towers, even the street lights. There are few cases in UAE that I've seen, even the plants that they are having. Those have also started getting connected with the IoT, so that gives a very nice way of ensuring that that device basically goes and tell how much water do you really need to put in on a particular day, when does it need it, when it doesn't need it. So it is going and saving a lot of water for the country. So we will see a lot of interesting cases. Those are there, and those will get emerged, and there's going to be a tremendous value out of it. All right, the future of IoT and its global growth. So the future of IoT looks really phenomenal. So we are expecting, there's a search done by Machina Research. They're expecting that the IoT revenue by 2025 is going to be 3 trillion. So this really speaks a lot. 3 trillion is a big number. And then if you talk about the number of devices that we will be having connecting to IoT, we're expecting 25 billion by 2025. So in the next 5 years from now, we are actually expecting 25 billion IoT devices worldwide. That's going to be a huge, huge number. And imagine the kind of complexity, the kind of challenges that it will all bring onto the entire world. If we look at the IoT market, this is all, again, will be growing at a very fast pace. If you look at the trend, 17, 18, 19, 20, and then immediately starting from 2021, I think it's going to be growing at a very fast pace. All right. So if IoT is going to be such huge, and if it is going to be so much important and will be integrated into day-to-day life, we don't see security in IoT. We don't see anything rich in security in IoT. And I'll just give you a simple illustration of the IoT security here. So as you see on the screen, when we say IoT, it is Internet of Things, but there is no security here. And which is what these gentlemen are having the conversation, that do you know the S in IoT for security? They say, no, there is no S in IoT. And the other gentleman says, yes, exactly, that's my point. While S is not there in front of it, but this is exactly inside into it, and it has to go into it. Without having S in IoT, the IoT would be meaningless. So IoT needs to be secured. If we just put the Internet of Things, put the autonomous systems, put all of these great technologies onto the planet, and imagine if we are not securing them, what repercussions it may have. Again, giving a very simple example, say if one's home is connected with all the IoT devices. And what if that home is not secured? So what impact it could have? What if some hacker gets onto your router, and then he will be able to practically control everything. One, he will be able to monitor what all you are doing. He can actually go remotely shut down your front doors. He can shut down your washing machine. He can shut down your TVs. He can do whatever that he wants or she wants to do. So security has to be a very key element in the IoT, and this has to be really taken very, very seriously. These are some of the hacks that we all have seen in the last couple of years. So while IoT was at a very nascent stage, people did not thought much about it. But with these hacks, I think everybody has realized that IoT security needs to be taken very seriously. And we'll give you just one example that if you talk about, say, Google Home, Alexa, Siri, uh, these are all of things that can be easily controlled or taken over, not by getting into those devices, but even by using the laser light. So I'm sure you will be able to find out that there are good illustration of this attack given in the YouTube as well. Maybe you can go spend some time, find out how these things can be done. But all that I'm trying to say is that IoT hacks are not that difficult as well. Similarly, you may all have heard about Volkswagen vehicle hacked via Wi-Fi spot feature. So it had a Wi-Fi spot feature, hotspot feature, and with that functionality, uh, the attackers could actually get onto the vehicle and they could hack this. Some more examples, and these are all again popular examples that I'm throwing out to you so that you all can relate why security is so much important for IoT. You may have heard about the OLED Wi-Fi baby heart monitor. That was an app which basically used to go and monitor the heart of the babies. And attackers actually got into this particular application, and then they were able to do a lot of bad things. Um, then in the healthcare industry, this was also a big news that the ransomware attacked one of the hospital, which actually resulted into the death of a patient. Fitbit, most of people uses that. It also allowed this spyware on official app store. So this was also a good research that was publicly available. The Jeep hack, you all may have heard it long time back, way back in 2015. The team of IBM could actually control the entire Jeep. They could really put the Jeep off the road onto from the highway, and they could actually go control the speed and everything what was possible. So these are just the same simple and few examples here, but I'm sure when you navigate to the web, you will find out so many other hacks that have happened, are happening, and attackers are not leaving any stone unturned to not hack any of these emerging technologies. All right, let me move on. So let me give you a brief snapshot of what are the IoT ecosystem is, give you some basics. And if I were to start the basics, so if you look at the IoT in principle, it has got three core elements. First, it has got the edge device, which is there at the bottom. These are nothing but these are really the IoT devices that we see in our day-to-day life. It could be washing machine, it could be smart TV, it could be a sensor placed in any of the device at our home or in our locality. So these are all the IoT devices. Ultimately, what they do is they go and connect to the gateways. Now, if we are at our home, the gateway is the router. If we are outside, there's some IoT device connected there. The gateway would be the respective gateway for that particular device. So the second element for the IoT ecosystem is the gateway. And third is really the cloud platform. So which is where all of these devices, by using the gateway, they are going and sending all the data. Again, taking back the example of, say, one of the machines, say for example, if you are having at our home, if it is going and sending a lot of data, so that data, by using the gateway, it will ultimately be going and storing onto the cloud. So it could be Azure, it could be AWS. There are many more platforms that have got created on IoT. So all of that will go and get stored. So these are the three key elements that are there in the IoT ecosystem. And once you understand it, then it will be easy for you to chalk down as to how do we need to secure all of these three. So just securing IoT device would not solve your problem. Just securing gateways would not solve the problem, or just securing the cloud platform would not solve the problem. So it has to be looked at holistically, all three components and the communication medium that we are having between all of these three, and all of them needs to be secured. Just to summarize, so these IoT devices are very small embedded systems at the bottom. They have got the firmwares, then routers are nothing but the gateways. They have got firmwares, typically Linux. So if they have got some vulnerabilities, people can go hack them. And then, therefore, it is important to vulnerability analysis on IoT devices. But how do you do that is a question. We will cover that later on. And then what I described is the cloud platform. So if cloud platform is not configured correctly, that could also give you a lot of issues. Okay, so why, again, a few more insights as to why IoT network security. So like we have discussed in the previous slide, no device is fully secure. So these are very small devices which really does not have the operating system like what we see in our machines or on phones. These are small devices with small RAM, small processing power. So it is very difficult to really find out how do we really secure it. So one, do we need to secure the firmware, then the communication that it is having, how do you ensure that the communication it is having gets secured? So all of those challenges are there. That's one. The other is the IoT security is currently limited. So the IoT security is still evolving. There are a lot of things that are taking place in this particular domain. A lot of technologies are getting implemented, and people are coming up with the newer technologies to ensure that IoT gets secured. The investments on security are limited in the IoT security space, but as we move forward, we will see that the investments would also be going high. And the functionalities before security is also limited at this point in time. But the real physical threats are there on health and safety, because we are all using all of these IoT devices in our personal lives these days. This is basically IoT threat landscape. I'm not sure how much visible it is, but just to give you a quick summary of it. So assuming that in the middle, these are the threats, and then those threats are again further divided. So first is, say, physical attacks. So somebody can actually go and physically attack some of the IoT device. Say, for example, somebody can come to your home, connect onto your Wi-Fi, just being a guest, and after that got onto your Wi-Fi and then try to access and control some of the devices. Or if you have, say, LAN ports at your home or wherever those IoT devices are, somebody can actually go connect the PC onto the LAN port, scan all the open ports, scan the vulnerabilities, and get onto destructing those IoT devices. The other is, one is that these physical attacks. The other is simply once you have the access, or once you know that these are the potential IoT devices that you want to target, you can do various type of attacks. You can do DDoS, you can do many other things to create the outages. You can also go and do, if the natural disaster happens, though, that also becomes a threat for IoT devices. Eavesdropping or interception hacking, that's also possible. If the system fails or malfunction, that's also a threat to IoT devices. if somebody is trying to spoof ICMP flooding, like I said, so DDoS, malware, those are also the things that are possible to attack. You can exploit the vulnerabilities, counterfeit them, target attacks, modification of information if it is exchanging the data. That information can be modified, the privacy can be compromised once you get onto attacking those systems. All right. The next thing I want to discuss is the IoT security attacks and challenges. So attacks possibilities, as we discussed, the attacks over the internet IoT ecosystem. So the sensors or the IoT devices, those are also, those can be attacked. So for example, once you attack the sensor, you can actually go drain the entire battery of pacemakers. The communication is not just limited to the LAN or Wi-Fi, Ethernet. It's also related to Bluetooth. Some devices connect to Bluetooth, so you can actually go intercept, or attackers can actually go and intercept the Bluetooth traffic. The data integrity is a big concern. If the data is being tampered along the way, that can also result into the entire decision-making process. The information privacy, which is a simple example of the toy app that I was showing you. This is basically eavesdrop on the children. This was a big news. So the challenges are basically there's a large attack surface and widespread deployment. There are limited device resources today. There are lack of standards and regulations. Safety and security processes needs to be integrated. Security by design is not a top priority. So the priority for anybody today, if I say to a large extent, is to push the technology into the market and try to win some early gains, and security is being treated as a later step. So that is not by design. So if somebody hacks into it, then people get aware and then they think, oh yeah, I need to go and secure these devices as well. But typically, ideally, if we are all from IT industry, and if you look at the basic philosophy of how we are all going and designing the IT systems, the data centers, security has been built from day one. So similarly in the IoT, the security has to be built from day one. The day it happens, we will see some ease in this particular space. Expertise is really one of the key area I want to focus. Not many people are really aware of the IoT security and what are the different protocols, what are the different ecosystems that we have talked about, the three aspects are there, and how to really go and safeguard all of these three aspects in a single pane of glass. So people may be thinking about securing just the IoT on the edge, or thinking to secure just the IoT at the gateway, or maybe at the cloud security. So how do you integrate all of these three things and secure all of these three remains a very big challenge. So that means somebody will have to look at it holistically, not by vertical domain. Applying security updates. So the other important thing is, say for example, if you compare a router with a small IoT device, a router is easy to do security updates because it has got very high processing power, it has got an operating system, you can actually go and update it. But since IoT device is very small, how do you update it? The one option could be over the air, but how do you ensure that the over the air update would happen? The other big challenge is that who needs to own the security of it? Say, for example, I'm a manufacturer of IoT device. I go and sell that IoT device to a consumer. He goes and takes that to his home. He connects onto his Wi-Fi. Now, my IoT device may be secure and my IoT platform may be secure. But if his Wi-Fi system is not secure, somebody got into his Wi-Fi and then try and damage that IoT device that I have supplied. So who's going to be responsible to or against whom the lawsuit would be filed? Would it be to the manufacturer who has built that product, or to the person who has been using this? So again, these are all gray areas at the moment. The other thing is, say, if another example, say if I am the manufacturer, I go sell it, and after that, say I give 3 years of AMC as part of the initial purchase. Now, what happens after 3 years? Who's going to take care of the security of that particular system? As a consumer, is he or she going to take the AMC of the IoT security separately? I think these are some of the things that needs to be thought through, which I don't think people have thought through it yet, but these are some of the challenges that we see. Those are there, and those needs to be addressed as we move forward. The other thing is the insecure development and unclear liabilities. So liabilities I've already covered, and insecure is also one of the things that when an application or the ecosystem or the device itself is getting developed, how do we need to make sure that those are developed by security? All right, I'll give you two attack scenarios of the IoT. So one, this is the first one, which is basically based on the Wi-Fi. So this is an attacker who is trying to get onto the Wi-Fi. And the moment he gets onto the Wi-Fi, then after that, this person would go and gather the specific information of the network, try to find out the vulnerabilities into the network. The moment the attacker knows that, he'll try to exploit the vulnerability, compromise the network, do the backdoor installation, update the systems with modified firmware. I think it is easier for everyone to understand it now based on the SolarWinds attack that has happened. Otherwise, before SolarWinds, if I were to explain you, people would still scratch their head as to how this is possible. But now we see that those backend codes can also be modified by the attacker. So it's easy for all of you to understand. And then once you have done it, you can easily, the attacker will actually go and compromise the device, take the remote system, and by doing this, the entire IoT devices will be controlled by the attacker. So this is one scenario. The other scenario is botnet or commands injection based. This is basically you go to a physical port, scan the port, access to the IoT device, do a code and command injection, obtainment of admin privileges, connection to device for CNC, then execution of the malicious script. The script deletes itself and runs in memory, spread and attacks over vulnerable devices, and then attack controls the botnet from command and control center. So this is another scenario, and there could be many more scenarios by which the IoT attacks are possible. The one I showed you by using the laser lights. This is quite interesting and one of my favorite slides. And if you just go to Shodan, Shodan.io, just do a Google search, and you'll be surprised the moment you got into Shodan. This is a real snapshot that I've taken by my search. If you go and just click on plant there, you will see so many IP addresses of the plants. When I say plants, means these are the IoT or connected devices. Those are located inside some of the manufacturing facilities. You'll be surprised that the IP addresses are openly available. What does that mean? So basically, as an attacker, somebody would actually take the IP address, just try to run the vulnerability, and might exploit that. So, but this is a scaling situation. If you look at it, this is the world map in US alone. So the total result it gave me was 2685 few days back. US alone, it has 804, Germany 515, Italy 220, China 100, Russia 83. And then it also tells you the services. So services means the manufacturer of this particular devices. So Siemens alone is 10860, and then the others follows. So, not just that, it also gives you a lot of other information, like, for example, the serial number of the module name, the firmware. So all of these information comes handy just searching a plant there. You're not doing anything else. I mean, nobody has done anything. At least I did not do when I looked into it. I just typed in plant, hit on search, and these are the information that came from Shodan. So a lot of information is available, widely open. There are a few websites which basically goes and shows you all the IP CCTV cameras, live CCTV cameras. Those are available. You go enter, just click on that. It will show you the live streams of the camera. So there has to be, and imagine this is the situation today. When we are talking about moving on to 2025 and increasing the number of IoT devices to a very exploit number, then imagine what kind of situation and what sort of map and the numbers we will have by 2025 or 2030 as the penetration goes high. So I think this is definitely a very serious topic, and I think a serious work is going on, and more this needs to be thought through. Okay, two more things that are left in this presentation. So one is the real life case study based on this smart factory. In the end, I'll give you a few tips. So I've just given you this case study. This is basically a smart factory. If you look at it in a factory, there are key processes. So I've listed down few key processes. I'm not going into the detail, otherwise this itself would become few hours of a presentation. So in the factory or the plant, typically they have got a loading area where the raw material comes, and then that gets loaded. Then that material comes into the manufacturing line where the material goes in and the manufacturing starts. Once the manufacturing is done, then it goes into the assembly line where the different part of the manufacturing gets assembled. And then from there, it goes into the testing and quality assurance lab where the testing happens and the quality assurance related aspect happens. So once the material is quality certified, then it goes into the packaging area to do the packaging. And then after that, it goes into the warehouse for the dispatch, and the actual dispatch process happens from there to either to another warehouse or to a distributor, and then the material goes to the consumers. So imagine if this is a smart factory and all of these processes are connected by using some machines, and those machines are having the IP addresses. Those machines are connected onto the network, and those machines are accessible within that particular factory. So what impact it could have if somebody gets onto the factory? I'll just give you 2-3 examples. Say, for example, somebody gets onto the smart factory, and after that goes into this section, testing and quality assurance. And in the testing and quality assurance, say if I'll give you the example, any example. So any device you think about, say for example, you are having a heater. Now the heater is supposed to operate at certain temperature. In the quality assurance, what if an attacker goes into it and increase that quality parameter from that temperature to say 30 more degrees Celsius? So that means you will still accept the product if it is going to that particular level. But if that continues for a long time at the consumer home, what if it burned? So this could have a very serious impact. The other impact could be, say, if you have gotten into the access of this smart factory, what if somebody goes remotely and shut it down? the kind of impact it will have, or if you go fine tune or change some of the parameters in the manufacturing line, when in the manufacturing line, if the manufacturing is supposed to happen by X parameter, if you add X plus 2, then the final product itself will get changed. And imagine if even if this continues for few days, the type of product that in the end it will have will be very different than what somebody had initially thought about it. So this is an example of smart factory, and in the smart factory, I've explained you the processes, and in these processes, I've just given you a few examples. So the idea was that I give you this so that you understand what are the sensitivity around the security it has and why it is important to secure each and every element of all the processes here. I'll give you a few tips. So if let's say somebody is designing a smart factory, so how do you need to make sure that the smart factory is built securely? Let me start with the basics. Number one, when you are designing the network for smart factory, you will have to have two different networks in the factory. One for IoT, one for IT, and the other is OT, or you can say IoT, operational technology. So you need to have two different networks so that all the core processes related aspects remains into one network that does not interact with the IT network that you typically have. Then a basic principle, restrict all the ports in OT network. So all the ports that are connected onto the machines. Say, for example, if you have, say, 50 ports, out of that 50 ports, you only have connected 10 devices. So you have to make sure that the remaining 40 ports needs to be disabled. The third is that even though those 10 ports are enabled, those 10 ports needs to be allowed with the MAC address. So say, for example, those 10 devices are supposed to connect onto those respective ports. So note down the MAC address of all of those devices and make sure in the network switch goes and allows those specific network MAC address only. If you can implement NAC in the OT network, there will be even a superior advantage. So basically, it will allow you to look at all the possible traffic that is trying to come in. Anybody who's trying to gain the unauthorized access, it will, number one, help you to give you that visibility. Number two, it will also go and control that. So you can implement that. You can also implement some of the monitoring systems. So some of the advanced SIEM. I won't name any of those, but there are a lot of AI/ML based monitoring systems in place, which can actually go and monitor, create the pattern of all the traffic that is happening into that network. And if there is any abnormality happens, say, for example, in a day between these 10 devices are sending, say, 5 MB of the traffic to the server. Suddenly, someday, I think this 5 MB becomes 5 GB. So those abnormalities can be detected and send it out. Then have a next generation firewall between the IoT, IT and OT network. So there would be some elements, like I said, so these devices will still need to send out the data. And when they send out the data, that data will need to go into the server. That server will be an IT network. So you have to make sure that when you're connecting or when a traffic is going between the IT and OT network, there is a close monitoring and control being put in place by using some of the best firewalls. You should ensure that you are not giving any incoming access to the OT network. If there is a need, say somebody wants to remotely troubleshoot, that needs to be allowed very strictly by taking all the due diligences, approvals, and for a very limited time. Outgoing access from OT to IT, again, should be on need basis after complete due diligences and the approvals. A next generation SOC, which can actually not just goes and monitor your IT, but OT network as well. And make sure all the OT systems that you have are patched regularly. This is a very key element. So say, for example, some of these systems that you have, say a robot or some of the PLCs or some of the MES SCADA systems, if they are not patched properly, while you have done all of these things, but if they are not patched, that means they may have some vulnerabilities. And if somebody gets onto it, it would be easy for anyone to get and hack those vulnerabilities, so or exploit those vulnerabilities. So make sure. I mean, these are all while these are all basics, but what I have seen, based on my experience, that people tend to do a lot of great things in the life, but they skip some of the basics. And I really feel that basics are some of the building stones for anyone, be it us, be it technology. If you're following the basics, then that will actually help you to build a very strong foundation. All right. Yeah, I think that's it from me. That's a very long lecture that I have given you on the IoT. Few last tips that I would like to give you on the personal life to be successful. So these are few tips based on my experience, and some of these things I use it in my life. So first and foremost, uh, no matter at what age or what level in the career you are at, some people may be at the beginning, some may have gone into the C-suite, but learning is something that one should not stop. So if you are not learning, someone else in the world is learning, and the opportunity comes to the people who are prepared. So you have to make sure that we are we are spending some time in our day-to-day busy life, but going and spending for the learning. The second is if somebody is studying for beach for academic purposes or for attaining some certifications or something, study hard. There is no escape to it. There are no excuses to it. Um, as we are seeing today's world, this is basically a technology world, and people who are well equipped with the technologies that are being day to day, this is the initiation stage. Those are going to be, they will sustain for a very, very long time. So this is the right opportunity for all of us to really go learn all the emerging technologies, which depending on your subject and the interest, please go learn all the emerging technologies, be it AI, ML, be it cybersecurity, be it the network security, whatever stream that you likes to, please go and learn. This is really, really mandatory. Again, attain certifications wherever this is applicable in your study pattern or learning pattern. Go and attain the certifications from the renowned organizations. It helps to prove your credentials to the potential employer. The next point is be sincere. So I've seen people who try to be low in life, be sincere. They tend to be more successful than the others. Strive for excellence. This is one of the very important points. So you should not try to study because you want to get onto the certification. You should not try to study because you want to earn a particular degree or really want to show off to the world that look, hey, I've gone and done it. Look for the excellence. So whatever you're studying, make sure that you get it 100%. Make sure that nobody else in the world knows that subject better than you. I think that's the simple meaning of excellence. And the